Hello friends, welcome to Knowledge Galaxy to rediscover the basics with Mayank Tiwari, a premier coaching and training channel dedicated to metallurgy studies and consultancy. Established to cater the needs of students, degree, diploma and AM/IIM metallurgy, competitive and recruitment exams for GATE, SAIL and various other government and private sector companies, metallurgical industries, working and aspiring professionals and whosoever seeking knowledge and information about various subjects and topics of metallurgy, ferroalloys, operational process optimization, productivity improvement analysis, etc. To impart practical industrial knowledge as per your specific requirements via tailor-made training sessions for your colleagues, employees and students, please contact me on knowledgegalaxy26@gmail.com or WhatsApp me on +919907144101 for scheduling and organizing the sessions at your place or via video conferencing. My dear friends, nowadays technology has improved so much that actual physical distance doesn't matter anymore. You can get all your doubts cleared by sitting at your home, at your comfort zone, just by contacting me over WhatsApp or phone, so that for your benefit, please do contact me for any of your doubts. My dear friends, I have made so many videos which are available on my YouTube channel. So I request you to visit my channel regularly and repeatedly and watch all the videos available there, so that you can gain maximum knowledge about the subject and topics, and also request you to watch all my videos from start to finish, so that you can gain the maximum and complete knowledge about the topic. My dear friends, as you know that training is costly, but not to train is still costlier. And when you are not having complete knowledge or don't get any information about the topic which you need to know, so you can contact me. If you don't find anyone who can help you to clear your doubts, you do contact me as soon as possible. And so right now in this video I am discussing about in this video, I am going to describe about yet another very important aspect of ferroalloys production operation, and the topic of the present presentation is the characteristics and properties of electrode paste for submerged arc furnaces. My dear friends, I have made many videos on electrode. Previous video was on the types of electrodes and paste, and this is the video which describes in detail about the characteristics and properties of electrode paste. And I hope this will be very much useful for you all, because the details provided here are very important, and the knowledge and information shared with you all here by this video is very deep and very important. So for the sake of gaining best knowledge, please do watch this video till the end. And before I start this video, I would like to request you to please watch the video in the next slide and observe the message given in that video.
As you have seen and observed in the video that no water can be filled in the pot if the pot is not aseptic, and also if the pot is already filled. The water can only be filled when there is some space in the pot. So my dear friends, I request you to keep your minds open for receiving the information so that you can receive the information correctly and gain the knowledge. But if you feel that you are already having much knowledge or more knowledge, or if you are not receptive towards receiving the new knowledge or information, you cannot gain anything. So for gaining new knowledge and information, please keep your mind open and be receptive for the new knowledges always. Okay, my dear friends, I hope the message conveyed in the previous slide and video is very clear to you all. So with this hope that you have gained the correct information and captured the correct information, now let us proceed to the presentation. To ensure a good furnace operation in a ferroalloy plant, the electrode paste consistency in the different quality parameters is one of the most important factors. My dear friends, you might have heard many times about the electrode breakages and electrodes paste problems in furnace operations while working with your company or anywhere. So these type of problems can be eliminated by having proper analysis of the electrode paste, and its quality parameters should be properly justified and as per the practices worldwide practiced. So let us proceed. The same furnace can operate well with different kinds of paste, adapting other parameters like slippages, current, furnace load, and so on. Physical parameters like electrode diameter, casing and fins design, and type of furnace, that is open or closed and or semi-closed, must be also be taken into account in the correct selection of the paste. When all these parameters are adjusted, the more important factor is the paste consistency to ensure a good furnace operation. Periodic analysis of the Soderberg pastes are important to assure these consistency. My dear friends, for your kind information, you might be knowing about the two types of electrodes mostly used in the ferroalloy production. The one is Soderberg type and the other is graphitized electrode type. Video about this is available in my channel, which is already available in my list. You can visit that video also. The main objective of this analysis is to control the properties of the paste which is being fed into the electrode are constant. Apart from analyzing the paste as a whole, some parameters of the raw materials of the paste are occasionally checked to detect possible fluctuations on their characteristics. Furthermore, when there is an electrode breakage in the furnace, a complete set of analyses is done to obtain valuable information which, together with the data obtained from the furnace control room system, is used to understand better the furnace operation. Analysis of the electrode paste. The main goal of the analysis is to guarantee that the properties of the paste are constant and to detect fluctuations in these properties. The analysis is composed of two main parts. The first part, which uses raw paste, is chiefly focused on the plastic behavior of the paste during the liquid stage. The second part, which analyzes baked paste at 900 degrees Celsius, studies the mechanical and electrical properties of the paste when it is baked at the same temperature of the contact shoe area. A standard paste analysis carried out at Ferro Atlantica's Sabon spray plant, including the main parameters controlled, is shown in the table 1, which is given in the next slide. So my dear friends, this is an standard paste analysis. So you can pause the video and observe all the contents of this table. This is very important from the perspective of any type of interview, furnace operation, day-to-day operation. So it is very important to know about the electrode paste quality. So whenever if you are going for any interview or working in day-to-day furnace operation, it is required that you must be knowing about the different properties of the electrode paste. So I hope this table will be very much useful for you all. Please observe it very carefully. My dear friends, just to interrupt you all, here I would like to emphasize on some special important aspect of Knowledge Galaxy. Here specialized subject-wise coaching classes and topic-wise doubts clearing are available. I am available for all of you to clear all your doubts, and especially for Diploma Engineering, Metallurgy and Mechanical students, Indian Institute of Metals, that is IIM, Part 1 and Part 2, and competitive and recruitment exams for GATE, SAIL and various other government and private sector companies, metallurgical industries, working and aspiring professionals. Here I would like to emphasize that whatever queries and doubts you are having in your mind regarding any subject or topic of metallurgy or any other ferroalloys production, operation, maintenance, so you can contact me for getting your doubts cleared. I will try to provide you accurate knowledge and to the best possible extent at the very shortest period of time, so that you can gain your knowledge, clear all your doubts, so that you can grow in your career, whether it is academic career, whether it is professional career, and so that you can develop and grow. So to continue with, here complete syllabus coverage for the students aspiring to appear in the forthcoming semester exams, that is December or June, I will be providing you all. So please contact me on knowledgegalaxy26@gmail.com or WhatsApp me on +91 99 071 44 101 for scheduling and organizing the classes or getting informations to clear your doubts via video conferencing, call or WhatsApp. My dear friends, you might have encountered that you might have been having many of the doubts regarding process, technology, why they are doing, why it is done, how it is done. So, and if you don't find any answer to them and nobody is there to guide you properly, so my dear friends, I am here available to guide you all, to make you know and grow, and so that you don't have any doubts related to your process, products, technology, syllabus, and I will make sure that all of your doubts get clarified and you know the topic and subject very well and completely. So again, let's move on.
Okay, let's now continue. So to start with analysis in raw electrode paste. The main parameters taken into account are: first, apparent density, ash and volatile content. All these parameters are determined with standard carbon laboratory techniques and give first important information. For example, apparent density is an indication of paste composition. Pastes with low densities normally are anthracitic, that is paste type 2, and pastes with coke in the mix have higher values of density, that is paste type 1 and type 3. Polarized light microscopy can confirm the presence of each raw material on the composition of the paste. Ash content gives information about the type of anthracite used because anthracite is the most contributing material to the total ash content. For example, an important variation in the ash content normally suggests a change in the type of anthracite used. Volatile content is a useful parameter to control deviations in the pitch content of the mix or a change in the type of pitch. In a smaller proportion, changes in the baking process of the anthracite or in the anthracite quality can affect the volatile content. Next, plasticity behavior of the raw paste. The desirable behavior of the raw paste implies to obtain good compaction and little segregation during the liquid stage of the paste, that is from 100 to 500 degrees Celsius. The tests of plasticity and briquette or cylinders compaction are the two analyses used to know the plastic behavior of the paste. The test of plasticity consists of a slow heating of a conformed cylinder of paste. At the end of the heating, the final diameter of the sample is measured to determine the percentage of deformation. The test is similar to the one used by the paste producers, but they do the test in the hot paste as it leaves the mixture, while the users must do the trial starting with cold paste. This can introduce some differences in the values obtained, but if the trial is done always in the same way, you can obtain valuable information. Plasticity is a good index to control the consistency in the fabrication of the paste during a period of the time. Problems during mixing can be detected by a deviation in the plasticity values in different samples. For example, few years ago, a paste producer changed its mixtures and decided to add some oil to the paste. Figure 1 shows the deviations observed in the plasticity of the paste after those changes. The figure is coming in the next slide. The two samples shown are from the same mixing cycle. Obviously, that paste was out of range in plasticity and caused problems in the electrodes. So this is the figure which depicts about the deviations on plasticity. There is a range of pitch content in which the plasticity is under control. Out of that range, problems normally appear. If the plasticity is very high, the material flows like if there were no dried aggregates in the formulation, and segregation is prone to occur in baked samples, as can be seen in the figure number 2 in the next slide. Segregation can cause a lot of problems, especially when the paste is charged in the shape of cylinders. One cylinder of paste with its properties out of range can generate a damaged zone enough to cause an electrode breakage. So this figure depicts the high plasticity and segregation. You can observe by pausing the video. When the segregated area reaches the contact clamp, the holes in the electrode make the casing withstand a great current flow that causes its melting and consequently a paste leakage and an electrode breakage, as shown in figure 3 is occurred. On the other hand, low plasticity can produce bad paste compaction because the paste does not flow enough to fill the casing, and then holes appear in the structure of the baked electrode. These holes can produce electric arcing and overheating on contact shoes areas. To study the compaction behavior of the paste, a briquette or cylinder compaction trial is carried out. So this is the figure 3 which shows the scheme of segregation. You can observe this picture by pausing the video. Different situations, different stages of segregation are depicted here. Now let us discuss about briquette compaction by heating. In this trial, a sample of paste, briquette or cylinder is heated under fixed low pressure as it is shown in figure 4 of the coming slide. This pressure represents the weight of the briquette charge over the liquid paste in the real electrode. When temperature is increased, the paste begins to flow and fills the mold. The apparent density of the sample is increased during the experiment and can eventually reach the maximum achievable density of the paste. The percentage of compaction reached at each temperature is calculated in relation to the maximum apparent density of the raw paste. By this method, we can have information about what kind of paste compacts better in the column, and we measure that in percentage at each temperature as shown in table 1. So this is the figure of compaction trial of the paste. Now let us discuss about the next property, which is viscosity. When the density reached in the compaction trial is equal or higher than 90% of maximum achievable density, the binder content of the mixture provides enough fluency to fill the casing of the electrode. After being guaranteed the compaction of the paste, the viscosity study is important in order to estimate the segregation properties of the paste, because the more viscous a paste is, the less it has the tendency to segregate. Normally, viscosity depends on pitch content too. Pitch in the paste must provide plasticity enough to compaction, but the amount of pitch must be the minimum possible in order to avoid segregation. The viscosity test consists of heating a confirmed sample under a cone like one represented in figure 5 in coming slides. In the graph of figure 6 in coming slides, the penetration of the cone into the paste at each temperature is expressed as a percentage of the displacement with respect to the total height of the cone. Pastes with values of penetration higher than 70% are little viscous and more likely to segregate, so they are not recommendable, at least for the ELSA electrode. To know more about the ELSA electrode, you can watch my other video, measurement and control of arcing in electrodes, which is the video is available in my list. You can watch that. So this test is also used to determine the starting temperature of the melting of the paste, which must be different depending on the kind of furnace, that is closed, semi-closed or open, and the kind of ferrodie production, that is very hot like silicon metal or less hot like ferromanganese. So this is the figure 5 which shows the penetration cone, and this is the figure 6 which shows the viscosity curves of different pastes. This paste 1, 2 and 3 I have already mentioned earlier in my presentation, this video only. Now let us have discussion about analysis in baked paste. The measurement of the mechanical and electrical properties of the baked paste at 900 degrees Celsius give valuable information to estimate the stress resistance and the capacity of transporting electrical current of the baked electrode. To obtain baked samples, two types of processing are carried out. First, pressed and not pressed baked paste samples as shown in figure 7 in coming slide. The pressed sample is molded by heating the paste to 160 degrees Celsius and then pressing it under high pressure. After that, the sample is baked slowly to 500 degrees Celsius. So this is the figure 7 paste compaction methods just I have mentioned. The not pressed sample is obtained by putting paste in a mold and heating it slowly to 500 degrees Celsius under constant low pressure. Then the samples are bagged to 900 degrees Celsius. Normally, if the compaction is good, there are no important differences between these samples, but sometimes the not pressed sample does not compact well and consequently the mechanical properties of this sample are poor. This is another indication that the plasticity of the paste is in the low range that can generate problems in the electrode. My dear friends, it is very much necessary and important to know about the mechanical properties and electrical conductivity of the electrode and so the electrode paste. So I am going to describe all these things here. Please be patient and observe the things very carefully. The electrode must have enough strength and flexibility to withstand the stresses generated during the normal running of the furnace. In most of the commercial pastes, strength and flexibility are opposite terms, so they must be balanced correctly. Electrical conductivity of the paste in the baked area should be enough to transport the current from the contact shoes of the tip of the electrode. The assemblies utilized to measure flexural strength and resistivity is shown in the figure 8 and 9 consequently. So this is the figure 8 which shows the flexural strength trial, and this is the assembly to measure resistivity. Information about thermomechanical stresses generated in the electrode with different types of paste can be obtained from mathematical modeling. In figure 10 in the coming slides, the mechanical stresses generated in an electrode made of a paste with a low Young's modulus are expressed in kg per square centimeter. The model predicts that a moderate flexural strength of 3 MPa is megapascal is enough to withstand the stress with sufficient margin of safety for this kind of paste. Taking into account the model of the electrode, it is desirable that a low value of Young's modulus in order to obtain less brittle and more flexible electrodes. The optimal range is between 2 and 4 gigapascals. A minimum value of 100 micro ohms meter after baking at 900 degrees Celsius for the electrical resistivity sorry, it is necessary to assure the flow of electrical current.
So this is the figure which depicts the data from mathematical model of the electrodes. You can observe different grades of coloring system and different nomenclature here. Now let us discuss about the segregation index. Samples baked in vertical positions can show differences in density between the top and the bottom part. This difference expressed in percentage is the segregation index. Good segregation indexes are those below 5%. Now let us discuss about shrinkage during baking. Between 500 to 900 degrees Celsius, the paste still has possibility of shrinkage, basically depending on the type and amount of pitch. This shrinkage is a main factor in the stress between the paste and the graphite core on the baking zone of the paste. It can be especially important on the nipple area. A dilatometer can be used to measure shrinkage of the paste. Values around 0.5% of shrinkage are acceptable. Samples from the electrode breakages. Now let us discuss about this. When a breakage occurs, it is a good practice to study the furnace parameters like current density, column position and slippage of the electrode and so on. To obtain further information, it is useful to take samples from different areas of the electrode as is shown in the figure 11 in the coming slide. The normal situation in the electrode is an increase in density and mechanical properties and a decrease in the electrical resistivity and porosity going from contact shoes to the tip. XRD, that is X-ray diffraction signals, increases because the paste becomes graphitized when the temperatures are higher. Common values of these parameters can be seen in figure 12 in the next slides. So this is the figure 11, sampling zones on the electrodes. You can pause the video and observe the different sampling zones, means from where the samples must be taken. And this is the normal values of different areas of the electrode. Okay, moving on. The graphitization process of the electrode can be determined using the X-ray diffraction, that is XRD technique. When the paste is near the tip of the electrode, it suffers big changes until it is graphitized. In addition to this, it is possible to detect CSI formation in the samples from middle area and from the tip. This CSI is picked out from the process during normal furnace operation by reaction between carbon and SiO. The CSI sometimes increases the mechanical properties of the electrodes very much in silicon furnaces. This type of reinforced composite made of carbon and CSI have never been observed in electrodes used in ferroalloy furnaces. In a normal graphitization process, the carbon paste must graphitize gradually from below the contact shoes to the tip. It is possible to measure that because the XRD signal of the samples suffers a gradual increase till the tip as the structure of the carbon is more ordered. An earlier graphitization sometimes observed in samples taken from contact shoes area of a broken electrode. It is always an indication of overheating or arcing in this area. That must be avoided because the overheating causes loosening of the carbon material and a diminution in the mechanical properties of the electrode. This is the case shown in figure 13, in which an earlier graphitization process on contact shoes areas caused a breakage. As shown on the picture of the anomalous graphitization, previous slides, the XRD signals in middle area is excessively high, even more intense than in the tip. This implies that the electrode reached more than 2000 degrees Celsius on that area when the temperature should have been around 1500 degrees Celsius according to the mathematical model. So this is the figure which shows normal and anomalous graphitization processes. This figure is for normal graphitization process, and this is for the anomalous graphitization process. My dear friends, I hope we are going so good so far, and now we have reached to conclusions. So with these conclusions, we will be concluding that whatever I have described in the presentation, the main part of that is that the paste consistency is an important parameter for the right electrode operation, and a periodic analysis of the paste from the usual suppliers or previous to a change of suppliers avoids a lot of problems in the electrode operation. Dear friends, I am providing you all the informations free of cost which are available in my YouTube channel. So do help me by watching all my videos. Do subscribe my channel. Regularly visit and repeatedly visit my channel. Do watch all my videos, contents, like the content, share with your friends, and so that I also get motivated from each one of you as you subscribe to my channel. I am very much thankful to all my subscribers who believe in me, have subscribed my channel, and like my content. So to motivate me further, please do subscribe my channel, increase the subscriber count, share with your friends so that others can also gain the knowledge. And my dear friends, all if you subscribe my channel, this will motivate me to do further better. So I hope you like the content and found the video worth. So again request you to please don't forget to like, share and subscribe the channel. Also remember to press the bell icon so that you can get the notification of the new videos promptly. My dear friends, here if you want to advertise about your product, services or company or anything else for gaining popularity in my channel, so you can contact me so that I can put your content for advertisement in my videos, forthcoming videos. So it will be a good platform to advertise. So do contact me as soon as possible. Thank you very much for watching this video till the end, and I am very much again thankful to all of you who helped me, who believe in me, and please do visit my channel regularly and repeatedly. Thank you very much again. See you in the next video. Thank you.